questions? Okay. Something I forgot to do, this was the ball being thrown into the air problem. And something I forgot to do was the graph of it. The sketch of the graph. Now, it's going a little bit off. So I'll point out some of the things I'm looking for. So what I would ask you to sketch a plot of would be position versus time, velocity versus time.
Do you want this recorded in our notebook? Can I go sticky notes?
It is, I think, useful to look at later.
What if I have this in my notebook?
It's up to you. I mean, as a general rule, I would recommend putting it in your notebook.
Okay.
So these are the three things I would ask you to plot. And one of the first things I'm looking for is your graph over here consistent with what you have answered over here? So first we need sort of time lengths here. And so it's going to look a little bit wonky because I'm going to set out A, B, C, and D sort of in even increments on my time axis, but in reality, C to D is much faster than A to B or B to C.
Where's D on the graph?
Where's D?
On that graph. There's only C and D. No, like in the
Chart. Oh,
there's A and B, B
you are
and B
correct.
and C.
Yes, I left it off. Positive, negative, negative, negative. So when doing this, I mean, if you're feeling daring, you can do it in ink on a test, but I would recommend pencil or something that if you're going to use pen, do it lightly. So I know it's positive the entire time. I have some sense that it starts out at some point, it goes away from the origin, then it goes towards the origin. So I'm just going to sort of sketch, it peaks at B. Just I'm going to do a dotted line for right now. I'm going to solidify it in just a moment. Velocity I know starts out at, is positive. It is 0 at B. So let's go ahead and mark my 0 down. It's positive. It's negative. I know it's not going to look like that, but just for the sake of demonstrating the iterative process. And
Is that
acceleration
an
is
A at the
negative the
bottom?
whole time.
Is
Pardon?
that an A at the bottom or a little Q?
That's an A
Okay.
for acceleration. And this is negative the whole time. So the first thing I do is I make sure that at least positive and negative and 0 matches what I have over here. The next thing that I would do is to make sure that it is self-consistent, because I know that my velocity time graph is the slope of my position time graph. Recall, velocity is the change in position over the change in time. So on a position time graph, this would be the rise and over the run. So I start out steep here, my slope is 0 at B, my velocity is 0 at B, that works out, and then my slope gets more and more negative. It sort of matches that. My acceleration, I know, is going to be constant here. So sort of working backwards. Well, try that. I know my acceleration is the slope of my velocity. And so if acceleration is negative the whole time, then the slope of my velocity should be negative the whole time. So if I draw a tangent line at any point, it should be it's sloping in the negative direction. And it is. So it's somewhat self-consistent. I know acceleration is constant in this particular problem because there's only one force acting on the ball during the duration of it, so my acceleration is constant. At least through the end of the problem. If my acceleration, now I'm sort of working backwards here, my acceleration is constant and I know it's the slope of my velocity. That means the slope of my velocity is constant. And so this needs to be negative and constant. And so this is the slope of that. It starts out big, it goes to 0, and then it becomes more negative. So this one should start out with some slope. It should steadily be decreasing until it get to 0, and then steadily increasing negative. And so that's going to be somewhat parabolic. And so this is a sketch of the graph to match that problem. So what I'm looking for here is one, again, does it match the answer I have over there? Yes. Is it self-consistent? In other words, is this the slope of that? Is that the slope of this? Yes. Is it differentiable everywhere? Now that language might be a little bit different for most people, but in essence, are there any sharp points? If it's differentiable, it should be basically a smooth curve like that. This is differentiable at all points, not including endpoints. That is not. And also, is it a function? Is it appearing in two places at once, or does it have two different velocities at the exact same time? That it should not. Sometimes people will get, it's the last problem on the test. They're getting tired and they just sort of rush through it. But if somebody did, something like that on the graph, well, that means at that moment in time, I'm hitting more than one spot. This is not a function. Questions on the sketching of a graph of that problem? Erica.
Which one did you say is not a function?
This is not a function.
Oh.
It does not pass the vertical line test. And from a physics point of view, if it were not a function, what we were claiming would be that at a moment in time, it had two accelerations at the same time, or two velocities at the same time, or two positions at the same time. And that should not happen in physics 151. As a side note, it turns out that in quantum physics, it is possible for an object to be in more than one place at one time. Until you look at it. And then it's in only one place. All right. Other questions? All right, let's take a look at the test level problem then. Oh, actually, before we do that, sorry to get you all excited to do that problem. What would the displacement time graph look like?
It looked like the position just shifted down.
Yeah. The only difference between position time and displacement time is the starting point. So you would shift it down so that the starting point's at 0, and then everything else is moves accordingly. So the displacement time graph just parallels that, just starts at 0. When is the position position versus time graph and the displacement versus time graph the same.
Starting point and origin point are the same.
Yes. You might want to just tuck that way in the back of your head for a minute. Questions before we do this problem? You know, as I touched it. All right, test level problem. So you've gone through, you've done the long problem, you're feeling good, and then you turn the page and it says sketch a graph of these things. I'll leave that there for now. More for the landfill. So this is position versus time. So I got A here, B, C, D, E, F, G, H, I, J. I could give more room on that than that. B, C, D, E, F, G, H, I, J. Close enough. This is velocity versus time. Excuse my back. Those are supposed to be lined up. First time, so it's A, B, C. Okay. Again, it's a sketch. It doesn't have to look perfect, but it does have to hit certain criteria. One, it has to match this. Two, it has to be self-consistent. And I guess, and then differentiable and a function. So I'm going to start out with just a crude sketch. I know it is 0 at D and A for position, so I've just marked those down. Or D and H. I know it's positive, it's negative before that and positive after that, so it's crudely. It's definitely not going to look like that in the end because this is more complicated than the one we just did. Velocity, I know, is 0 at A, F, and J. I know it is positive between A and F, negative between F and J. And again, I would do it in pencil on paper as part of a test, and we have a bag of pencils around here somewhere. There it is. So if you need a pencil, we can accommodate. And some of the erasers even work. And then acceleration is 0 from D to E. And to G to H. It is positive, then negative, then positive. All right. So I got at least a first shot here. I know that it matches what I have there. It is consistent with a previous answer. It's not self-consistent yet. But at least we've satisfied step one. Questions to here? All right. I know that my acceleration is going to be constant from A to C. Because there's nothing to change it. There's no additional slope to it. It's a straight line, intended to be a straight line. And so I know that it is constant here, it's a different constant here, it is 0 there. My acceleration is greater at this, my acceleration will be greater at the steeper slope than it is here, because one, it's not as steep, and there's friction. So my acceleration is constant, and then it goes to a greater constant. So from A to C, it's constant. And probably should do that a little bit lighter. From C to D, it is a different constant. And then it goes down to 0. Well, if my acceleration is constant, remember this is the slope of this. So from A to C, my velocity should be constant. It should have a constant slope. Right, draw that straight. From C to D, it's steeper, it's a bigger constant. D to E, my velocity, my acceleration is 0, which means my velocity doesn't change. So that should be flat topped. From E to F, my velocity is 0 at F. It'll be, when it gets back to the flat area, it'll be going as fast as it was before, just in the other direction. So at G, it should be going about like that. And then it starts to slow down. Let's see, from H to I, it has a positive acceleration, it should match this. And then it should have an acceleration in that last little bit that is less than it started with. Yeah, lesser magnitude. And so my velocity slows down, and then it slows down again. Let's see. Oh. My velocity is constant because my slope is constant. And then it is steep, and then not as steep. So it's just another iteration going through, just making sure the slopes match. Now up here, my velocity is steadily increasing. So if my velocity is steadily increasing here, that means that, let's see, it's positive. So my slope should be positive, getting bigger. And then at this point, it gets even bigger until I get to, slope is, so it's C, so it's getting bigger, and then it gets steeper faster. Small kinkish thing there. At D to E, this is constant, so my slope is constant. E to F, actually then I get to E. It's going to slow down, it's going to peak at its farthest distance at F, and then come back down to G. And then it should be relatively constant. From G to H, I. It will slow down quickly, and then plus. All right. So I've got another iteration there. I'm almost there. And it's possible that this would get full credit. I'd have to take a look at it one more time. First off, my position is 0 at D and H. 0 at, oh, found a mistake right there. I ignored the fact that it is 0 right there. Then it is straight. Okay. It is 0 at D and H. It is positive in between them and negative on the outsides. Check. My velocity is 0 at A, F, and J. Yep. Positive between A and F, negative between F and J. Check. My acceleration is 0 from D to E and G to H. It is positive on the outsides and negative in between. Check. Consistency. I start out at a slope of 0. It gets steadily bigger and bigger and bigger. It reaches its peak at D. They're not lined up, that's part of what's messing me up here. It peaks at D, it's flat and level. It is farthest away at F, then it comes back there. At F, it reaches its farthest distance, it's 0. I'm at a peak, it's 0. And then I'm at 0 here. My slope should probably level off a little bit more. And then down here, my acceleration, I have a positive slope, steeper positive slope, slope is 0, negative slope, 0, positive slope, positive slope. And now it's a matter of connecting the dots so it's differentiable everywhere and a function everywhere. This one's easy.